Welcome all to next class of gravitation, in which we'll basically discuss about the gravitational field due to infinitely long solid cylinder. So in the previous class we discussed about that infinitely long hollow cylinder. Now I'll discuss about solid cylinder. So in case of solid cylinder, or in case of hollow cylinder, we know that as it is in case of solid cylinder, we need to consider mass also inside this region. So in hollow cylinder, we are assuming that there is no mass inside, but in case of solid cylinder, this is like mass is inside this one. So due to symmetry, the direction of gravitational field strength is perpendicular to this plane, and it is in inward direction. That means over here, direction of gravitational field will be something like this. So if you are observing from different points, we can say that these gravitational field lines are perpendicular to the surface and inward. So all these gravitational field lines are basically concentrated on this line. That's why we are considering this line symmetry, or we can just assume that the same as like total mass is concentrated on a thread. And we already discussed the equation for a gravitational field due to a long thread also. So in case of solid cylinder, due to symmetry, the direction of gravitational field strength must be again radially inward direction and or towards the axis of cylinder. So if we wish to find out the value of acceleration due to gravity or gravitational field strength at any point, we can just assume that due to symmetry, we can consider that the whole mass of cylinder is concentrated uniformly on its axis, and for outer point it will just behave like a thread or like a long wire then we need to find out the value of, we know the equation for gravitational field due to a thread. So we know the equation for gravitational field due to infinitely long thread as G is equal to nothing but 2G lambda divided by X or divided by R, where X is the distance from the axis of that cylinder. So first we need to find out what about the value of its like lambda. So it's linear mass density. So we can write linear mass density is nothing but mass per unit length. So if you are selecting a cylinder of mass m, so let's say if you are considering a cylinder of mass m over here, and take it as the part of the cylinder of mass m, and take it as its length is equal to L. So we can find out what about the value of its mass per unit length, as mass is inside the cylinder, or mass is uniformly distributed inside also. So we'll use the density, that is mass per unit volume. So we can write as density is mass divided by volume. Mass can be written as nothing but density into volume. So mass per unit length is divided by L. So we can write density into volume. We can write it as area into length. Area of cylinder of radius r, we can take it as area is pi r square, is cross sectional area, and length L divided by L. So we'll get its linear mass density as nothing but rho into pi into r square. That means if we are considering this solid cylinder as a wire or a thread, then its linear mass density, mass per unit length, is its volume density into pi into r square. Now we can find out what about the value of gravitational field at different points. So we are considering that there is a solid, infinitely long solid cylinder over here, and we are going to find out what about the value of gravitational field at a point P, which is at a distance x from the center. So in the first case, assume that this point P is outside, so that we can write the case 1, that is if the value of x is greater than r. X greater than r means the point is outside. Take it as the radius of cylinder is something but capital letter r. So if this point is outside, so we can use the equation for a gravitational field due to a cylinder, that is 2g lambda divided by x. So we can write this is equal to 2 into g into the value of lambda. We just calculate as a rho into pi into r square divided by x. So the equation for a gravitational field outside, that is 2g rho pi r square divided by x. And you can observe that outside point, the value of gravitational field is inversely proportional to x. Now we can consider the second situation when it is on the surface. So if you are considering a situation that in case of a solid cylinder, if you want to find out the value of gravitational field on the surface, so the case 2, we can write the value of x is equal to nothing but r. The value of x is equal to r, so in the previous equation, that is g is equal to 2g rho pi r square divided by x, we can just put the value of this x is equal to r. So we can observe that 1 r over here and 1 r over here get cancelled. So the value of gravitational field is going to be 2g rho into pi into r as the equation for a gravitational field on the surface. and which is a maximum value. Now in this third case, we are going to find out what about the value of gravitational field which is inside this one. So if you want to find out the value of gravitational field inside, so we need to consider a part something like this. So the cylinder that we are considering is having a radius that is equal to x. So if you are writing the equation for a situation, or take it as a case where the value of, take it as case 3, when the value of x is less than r. So if you are using that equation, g is equal to nothing but 2 into g into, let's say we are putting the value of lambda dash over here divided by x, because now we are not taking the entire radius r, because the equation for lambda was nothing but like rho into pi into r square. Over here the radius is only up to x, so we cannot take r over here. We should write rho into pi into x square. So if you are putting this value, it's going to 2 into g into lambda dash. Instead of lambda dash, you can write rho pi x square divided by x. So this x and this one get cancelled, so we can write this is equal to 2g rho pi x is a value of gravitational field. So just remember this equation for, or we can say that this is directly proportional to x. So if you are drawing a graph just showing the variation of gravitational field with respect to distance x from the center of a solid cylinder, so the equation or the graph will be something like this. From center to surface, center the value of x is equal to 0, so gravitational field is equal to 0. So the value of gravitational field first increase with respect to x, and it will reach its maximum value, and it is inversely proportional to x, and at infinite it is going to be equal to 0. So this is a variation of gravitational field with respect to distance, let's say that is x. Hope so that you understood whatever the things we discussed in this class. If you are having any doubt, please contact. Thank you.